Okay, let's talk about the law of sines and law of cosines, which are used to solve for side lengths and missing side lengths and missing angles in triangles that are not right triangles. I've drawn here a triangle, just tried to be a random generic triangle. As it turns out, it looks kind of isosceles, but don't let that fool you. This triangle could be acute, could be obtuse, could be scalene, whatever. But just the idea of the law of sines and law of cosines and how it works, or how they work. The law of sines is one of the easiest proportions ever to remember, and it relates the angles and the sides across from those angles in such a way that we see the proportion is such that the side lengths increase according to the sine of the angle across from them. We all know from geometry that the largest angle will have the largest side across from it, and the smallest angle of a triangle will have the smallest side across from it. But what is the exact way in which those things are related? Well, they're related proportional to the sine of that angle, not just the straight up angle. So the law of sines is used anytime you have an angle and a side across from one another. So like if we had a and little a, and just any other piece of information. I guess the one time that might seem strange is if we had, you might have to think through that just a little bit. Let's say we had an angle of 80 degrees here and an angle of 40 degrees here, and we were given, let's say, this angle, this side length over here, let's say this is little b and it's 5. Well, we weren't given an angle and, that would be big B up here, we weren't given an angle and a side across from it, but we kind of were, because we were given these two angles being 120 as a sum, which means this third angle up here must be 60. So we really do have an angle and a side across from it and one other piece of information. So as long as you have that, you're good to go with the law of sines. If you have a situation where you don't have that, let's say you have either 3 side lengths, you could have like 15, 14, and 13 here, and you don't have any of the angles, you can use the law of cosines, which looks like this. Doesn't matter which letter you pick. Let's say you're looking for little a squared. That's equal to b squared plus c squared minus 2bc cosine of the angle associated with that side length that's out in front. Similarly, b squared equals c squared plus a squared minus 2ac cosine of big B. And lastly, the only other version you could have is c squared would be a squared plus b squared minus 2ab cosine big C. Of course, you can see all 3 lowercase letters are used in this formula, but to get one of them, you just need the other 2, but you need that angle that's in between these 2 sides. So in other words, between side A and side B is going to be angle C. But let's say you have all 3 sides like we do in this one. You could fill in, you have 15, you have 14, you have 13. You could fill 15 there. 14 would be a squared, and 13 would be, well, a squared would be 13 squared. I'm sorry, 14 squared. B squared would be 13 squared, and minus 2 times 14 times 13 times the cosine of angle C. So the only thing missing would be the cosine of C. So let's see, you would use this in the case of having side, 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 or side, angle, side. Oops, side, angle, side. This you would use for like side, side, angle, side, angle, 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 side, angle, I guess that would work as well. But basically with law of sines, it's just, do you have an angle and a side across from it and one other thing. So there you go. You should definitely kind of keep these formulas in the front of your brain. This one's so easy to remember, but this one's really not that bad either, because of the patterns that involve it. You don't have to memorize all 3. As long as you know one of them, you know them all. But just recognizing that you could use, say, law of cosines to find an angle if you had all 3 sides. And that's all she wrote.